what I wanted to do today is to share with you some thoughts on what really changed with generative AI compared to the classic machine learning landscape. So I won't spend time on what we have been doing for years and years, applying machine learning algorithm to a plethora of use cases. If you are interested, you can have a look at my website. I have published many white papers and videos. For the sake of illustration, we used it, for example, in this case, for IoT devices to optimize routing, for anomaly detection in a number of areas, such as wireless, to detect some anomalies, to filter the noise and false alarms. We use it for root cause analysis. We used classification machine learning algorithm in order to help with the classification of devices, for example, or for spoofing attack detection. This is yet another example. Obviously, the area of forecasting has been one of the top use cases for machine learning, and we use it in this case for the predictive internet that we released a few years ago. But what I want you to do today is really to say, okay, when we step back, what are the main differences between the classic machine learning landscape and generative AI? So we all know that generative AI has exploded since it has been introduced thanks to OpenAI in about 18 months ago now. And now when we step back a little bit to analyze the differences, the first one that I would like to mention is the path to productization. And it's fascinating to me to see that the barrier to entry was in the past fairly high. Why? Because you had to have a team of machine learning engineers with data scientists and of course experts in the field. And then the process was fairly well known and I would say fairly deterministic. So you would start with a use case, which is always what I suggest to people to do without jumping on the technology. Then you would collect some data set, do some cleansing of the data to make sure that you have the highest quality of data. And then what you would do is to select one or two algorithms and then start to do some prototyping. You would be monitoring the efficacy of a system, which is fairly synonymous of the algorithm in many of these use cases. And then based on that, at some point, you would decide to go to the alpha and then the beta testing and then release it as a product. So I would say that the barrier to entry was fairly high to moderate, maybe, especially that now we can use different platforms that can help you bootstrapping the project. But it was a fairly deterministic path. Now, if you step back a little bit and you look at generative AI, what is extremely interesting is that all you need is basically an API. And very quickly, you can come up with a prototype. So when you look at the path to productization, you would very much see a curve that looks a bit like this. In other words, you can very quickly come up with a prototype, but the path to productization may end up being a little bit longer than with a classic machine learning. And I think this is something that people need to understand if they want to deploy this kind of product. So, now let's have a look at different metrics. Well, we talked a little bit about the barrier to entry, and I still believe that for classic ML, it may be high. I would maybe say that it's maybe like moderate these days, but definitely generative AI is a low barrier to entry. You can, as I said, come up with a prototype very quickly. If you look at the cost now, the cost is very interesting because with the machine learning, you would basically have something that is very much tied to a use case. And it could be very cheap or it could be a little bit more costly if you end up using a very large data set, for example. The training cost may be higher. And if you want to use it in production, you may have to do some tweaking to make it as cheap as possible. Let's put it this way. If you look at generative AI, the cost, maybe from low to medium, because unless you want to train a foundational model which is unlikely to be the case as an enterprise. And because in this case, it would be extremely costly, obviously. But if you want to fine-tune a model, should you have to fine-tune the model? Because in some cases, you may simply do some prompting optimization, RAG optimization, as opposed to even fine-tuning the model. Then in this case, the cost of generative AI is fairly low to medium. And even if you want to do some supervised fine-tuning with LoRa plus, these techniques, you can actually make it fairly lightweight. The interpretability is also very different. With machine learning, it depends on the type of algorithm that you use. If you use a decision tree, a gradient booster trees, and other type of algorithm, it may be fairly, I shouldn't say easy, but it's doable to do some interpretability. Decision trees are highly interpretable, but of course, if you use a deep neural net, although we are making some progress, it's still fairly difficult to do. For generative AI is actually very, very hard, simply because the architecture of a transformer is by itself very difficult, but there are dependencies between components as well. So if you want to interpret the whole system, it may be challenging. I'm very hopeful when I see mechanistic interpretability, path towards monosemanticity. There are many research areas in order to try to interpret what's going on, but still the bar is very high. When you look at reliability, is also something very different. With a classic machine learning algorithm, you can, in most cases, achieve a fairly high reliability. Should you have, of course, the proper data set, the expertise to fine-tune the system, which is, of course, a necessary condition, but you can, without a doubt, in most cases, you can achieve fairly high reliability, and you know what is the reliability looking at different metrics like the F1 score or the precision recall and this kind of metrics for classification. Whereas in the case of generative AI, and this is really one of the main challenges that I see today, the reliability may be between medium and low, and we may not have always the ability to stop the system from doing some hallucinations. There are multiple ways of mitigating that risk, doing a fact-checking, using ensemble methods, and we're working very hard to make it as reliable as possible, but this is clearly a difference between the two. The number of dimensions are different as well. If you are taking into account a classic machine learning algorithm like a classifier, for example, or a regressor, of course, you can play with multiple dimensions, but at the end of the day, you can even use some algorithm that will do hyperparameters optimization, and the number of dimensions is usually not so high. Of course, I'm not talking about the size of a vector, the number of features being used, but I'm talking about the dimensionality of a problem space, whereas in generative AI, there are many, many dimensions. What do I mean by that? Well, if you look at the system overall, you have many ways of tuning the system. You can play with prompting. There are many strategies. You can use a chain of thought, react, and tree of thought, graph of thought. You can use long windows, smaller windows. The RAG is, of course, extremely important as well. There are multiple strategies with a lot of parameters that you can use for the RAG, and that's true as well. With the model itself, you can even have multiple agents working together. And so if you look at the overall system, there are a lot of dimensions, and these components, they have very high dependency. So if you really want to work on generative AI, that's something to keep in mind. The efficacy evaluation is also tricky, because if you take, again, a classifier and you look at the recall and precision, these are very simple metrics to understand. We can evaluate also the efficacy of the system by looking at the efficacy of the algorithm, because they are fairly synonymous. In contrast, if you look at the system with generative AI, as I said, you need to have a look at the metrics that are related to the objective you're trying to achieve. And depending on what you want to use it for, you may not always have a very clear ground truth, and you may have to design the metric. I published a post going into some details, And people may tend, I believe, to focus a bit too much on the well-known metrics, such as a human eval, and there are many, many types of metrics that are related to a given class of problem for an algorithm. Very interesting metric for sure, but they may not be able to reflect the efficacy of a system for the problem at stake. And this is something people need to be very attentive of. The pace of change is also quite amazing. And I never thought that I would be mentioning that a fast pace of change may be a challenge. With a classic machine learning algorithm, we've seen many improvements over the years. Now we're talking about weeks with generative AI. So when you develop a product that you're targeting for large-scale deployments, and every week you have another approach, then it may become challenging. I will post a video soon looking at all of the dimensions of generative AI, and you'll see that when you look at all of the progress, and there's no reason why the pace of change would slow down, it may be a little bit challenging sometime when you look at that. Okay, so the last piece that I wanted to mention is generative AI, in my opinion, is not a replacement of the classic machine learning algorithm. In many cases, by the way, you may want to use simply statistical models. I never thought that we had to jump to the latest technology, and there are still a lot of use cases for which the classic approach is still highly interesting, including classification, regression, and forecasting. Okay, so what does that mean? Well, first of all, as always, try to use the right technology for the right problem, and people may tend to over-rotate sometimes to the latest and greatest. I do believe that building a strong platform that you could use for systematic performance evaluation of a system is a must, especially when you have a lot of dimensions. And, trying to play with trial and error when you have, for example, you have a very complex machine learning model or a transformer or an LLM, in this case, trying to tweak a little bit the prompt, and then you have the next release of a model that is going to disrupt completely your product, maybe in a good way, maybe in a bad way. You never know exactly. And some people may tend to do a lot of trial and error, and I believe this is very fragile. So the only way is really to have a strong evaluation platform that could be used in a systematic and scientific fashion with rigor, so that you can use it with multiple metrics maybe, but reflecting how well the system is doing. Then at that point, if you have some good analysis of the failure modes, you can really start understanding where you need to tweak the system and play with the different parameters of a component. Then what I would mention is that indeed reliability may be a concern. We do see major improvement in this area. What we call sometimes epistemic humility is an open issue. These kind of models may not have a tendency to stop. They may want to hallucinate in many cases, but there are multiple technologies that are being developed in order to mitigate that issue. I've been working on that with my team for some time also, and there's no reason why this problem may not be solved. But of course, you need to pay attention to that, because that's a big difference with classic machine learning algorithm. And of course, you need to adapt your engineering process to handle this kind of fast pace of innovation with generative AI. Still, the message in this presentation is not to say that there are a lot of issues with generative AI. All I wanted to do was to provide you some feedback using our expertise and experience developing systems with classic machine learning algorithm and generative AI, because of course, when you know about these challenges, you are well better equipped to face these kind of problems. And again, I'm super optimistic. I think that generative AI will be used in many, many industries, and the future is very, very promising. Thank you.